Good morning to all. I would like to start my presentation with a statement taken from ICRC's framework for sustainable development. The International Committee of Red Cross strives to position itself as a pioneer among those humanitarian organizations which are sincerely committed to meeting their social, economic, and environmental responsibilities. Next one, please, Anissa. Indeed, what we are trying to apply is basically basic, though important principles of bioclimatic architecture and sustainable construction. We adapt design approaches that takes into consideration the regional climate conditions. We're introducing passive design strategies to reduce the building energy demands needed to achieve thermal comfort, which leads to long-term energy savings. And also, we're using the available local resources and local construction techniques to ensure a feasible local maintenance and reduce the environmental impact, if you like, of material transportation. Next one, please, Vanessa. I would quickly move to the presentation of three ongoing projects. The first two are physical rehabilitation centers in Mopti and in Bangui, and the third one is the new ICRC regional delegation in Nairobi. I appreciate that three presentations of three projects is in a short time is rather challenging if you want to go to details. Although, frankly, my intention is to provide you with a glimpse of our current activities towards energy efficiency and sustainability and designing for sustainability. And I will start with the project in Mopti. ICRC's physical rehabilitation program can be traced back since 1979. Physical rehabilitation, for the ones that they are not aware of, includes the provision of mobility devices such as prostheses, orthoses, walking aids, and wheelchairs, together with the therapy that enables people with disabilities to make the fullest use of their devices. This project is a partnership between the ICRC and the state of Mali. Its position in Mopti, a hub between the south and the north of the country, will prevent patients from making long journeys, often too expensive to access care. Our design approach, considering Mopti's dry and hot climate, was to consider necessary mechanisms to cool the buildings. Indeed, for reasons of sustainable development, as well as energy and maintenance savings, operating costs, the architectural concept proposed solutions to limit temperature regulation by air conditioning. In terms of architectural concept, the architecture of the building is designed to optimize passive cooling of the spaces, which this makes it possible to limit the need of air conditioning, and thus reduce operating costs, if you like. This concept, as expected, notably determines the irradiation and the layout of the building spaces, the choice of construction materials, the openings, the significant vegetation, with a view to developing a bioclimatic architecture. In terms of thermal comfort, which is rather another complicated notion, is influenced on a combination of different factors, like the air temperature, the average radiant temperature, the air speed, humidity level, occupant metabolism, if you like, and yeah, why not the occupant's clothing sometimes. The difference in temperature between day and night in Mopti is significant. So the use of materials with a high thermal inertia was was imperative. Please, next slide. In terms of architectural design, while certain factors are independent of construction, thermal comfort in a building can be largely influenced by constructive choices. Building shape, orientation, construction details, choice of building materials, coating, protection, name it. Optimization of different mechanisms for solar gains, natural and controlled ventilation systems as well. The layout of the buildings, as you can see in your screen, form two islands, each articulated on an inner courtyard. The two blocks meet in the center to house the reception area of the center. A gap between them defines two outdoor spaces. One houses the main entrance and the car park, and the second at the back, the sports ground and the service entrance. The total floor area of the building is approximately 2,700 square meters. In the area where the building, the center is located, there are electricity and water networks. The non-air conditioned parts, which is on the top of the screen, this yellowish component of the building, and on the bottom right, and on the bottom with this bluish building, which is the PO and the physio, and the accommodation to your left, the green square, are arranged as far as possible so that the openings are to the northeast and southwest, in the direction, in other words, of the prevailing winds, in order to optimize natural ventilation. Spaces between the closed areas create openings or relaxation areas and provide, if you like, additional air circulation in the inner courtyards. Talking about protection from solar gains, it is important to note that we have planned to plant 74 trees and shrubs, and also to cover the areas with grass. Next slide, please. The criteria for the selection of materials are very, very important component of every single project. Were based on the local availability of materials, of course, the physical characteristics, structural and thermal properties, the availability of the skilled labor, the speed of implementation, the cost to build, and the maintenance necessity and cost. Some examples of main materials used include the stabilized soil bricks for walls and ceilings, bamboo for external roofs covered in translucent roofing sheet to protect the bamboo from exposure to weather effects, while allowing at the same time natural light to pass through. Galvanized steel sheet for roofing with a false ceiling of timber and covered with reed mats. Natural stones for pavements and for parking. There were also other materials selected. Next slide, please. Why stabilized soil bricks? The project adopted the use of the SSB bricks on its walls and ceiling vaults for various reasons. One of them is the brick measure, the size of the brick. Of course, that it uses minimal cement content from 5 to 10% and requires no plaster for future maintenance. The bricks are easy to work with and have unique properties, allowing a natural regulation of the atmosphere in the dwellings. In addition, the stabilized soil brick can store heat and solar energy and release it in form of radiated heat when temperatures drop, especially overnight. The SSB offers great resistance. The compressive strength tested was approximately 60 bars, 60 kilogram per square centimeter. The production of the stabilized soil bricks uses 1% of energy compared to fire bricks. Hence, we have less CO2 emissions. And of course, just-in-time procurement. The production was done on site, ensuring no need for transportation of the bricks, and were used as soon as they were cured, approximately 21 days. The materials were all sourced nearby in the area, and yet, if you like, the debris of cut brick being predominantly made of natural material, disposal to the natural environment is not harmful. Next one, please. This is another project. This is another physical rehabilitation center in Bangi this time. The project currently is on the procurement phase, and we expect in a couple of months the construction phase to commence. The center would be connected to the electrical grid and also to the public water network, although the later one, the last one, is not that reliable. In terms of public waste water system, there is nothing available in the area. As such, the use of septic tanks have been considered. Next slide, please. Once again, our design approach took into consideration Bangi's climate and environmental data. In this project, also the principles of bioclimatic architecture have been applied, aiming to adopt low-tech passive cooling solutions to avoid air conditioning and consequently, if you like, to reduce the electricity demand. Next slide, please. The layout of the building forms an island articulated on an inner courtyard, as per the example of the similar project in Mopti. In this particular project, though, we were not able to find adequate or reliable data, if you like, about wind. Hence, a design decision was taken to create gaps between the building blocks, aiming to facilitate the air circulation among the buildings. Next one, please. As per the example of Mali project, the use of the soil stabilized bricks have also been adopted in this project. Once again, the criteria for the selection of materials were based on same principles as previously: availability, physical characteristics, availability of skilled labor, speed, cost, maintenance. You will see on the table on the upper right side, the design decision was to use the double soil stabilized bricks, as well as in Mopti. And you'll see what is quite impressive is the U value, as well as the time lag and the temperature damping. So basically, the soil stabilized bricks being super energy efficient and sustainable at the same time, and it provides better characteristics than other materials. Next slide, please. I would like to emphasize on the rainwater collection and use in this particular project. You could appreciate that each project is different. Even if we apply similar principles, every single time we try to also to contextualize our design decisions and solutions. In this case, there are two rainy seasons. The small rainy season, the so-called mango rain, which is between February and March, and the main rainy season from August to December. All year round, there can be shortage of water in the network. It's not reliable, lasting from a day to several weeks. So collecting rainwater and storing it, it's a sustainable way to have water available during water shortage and reduce the need of water tracking. The project also aims to limit water consumption by using rainwater collection. Again, the solutions chosen use simple techniques with low maintenance to ensure the sustainability of the proposals. A main rainwater collecting tank and small autonomous tanks with direct use for toilet flushing. Next slide, please. The last project that I would like to bring up to your attention is the new ICRC regional delegation in Nairobi. In this project, it's really a holistic approach to sustainable design. The aim since the very beginning was to reduce the operational and maintenance cost, and yet to reduce the delegation carbon footprint. Next slide, please. In order to achieve our sustainability goals, the new regional delegation will be targeting by a LEED certification. LEED certification, for those who might not be aware of, for buildings is a world-renowned benchmark for sustainable green buildings. It is accepted worldwide as the highest standard for sustainable buildings because of its stringent criteria for certification. As such, a LEED specialist has been appointed to assist us through the design and construction phase. This project is also currently at the procurement phase, and we expect in the next 3 months the construction phase to commence. As you will see, it's an integrated process to achieve synergies across many disciplines. This is why we have the LEED certification, we have the site management, the water use efficiency and water treatment, the energy use efficiency, the natural ventilation, very importantly, the influencing user behavior, and the sustainable building filters. The next slide, please. Our design approach considered not only the bioclimatic architecture and sustainable construction principles, but also this time the requirements and the preconditions arising from LEED. The plot area is approximately 36,000 square meters, and the total floor area to be built is approximately 7,800 square meters. Special consideration has been given into the groundwater recharge, the preservation of the site, and the storage and recycling during construction. For example, in terms of tree management, an initial study carried out to preserve as many as possible trees by identifying which one of them were old, dead, portraying a risk of falling, or there were some important species. And accordingly, the design, considering all those trees and the position of the trees, the design was aligned on those principles. The next slide, please. In terms of water use efficiency and water treatment, the target is 95% of rainfall to be harvested. Rainwater surface runoff flows directly to the pond, which is in the middle of the site. It will be an artificial pond. For areas lower than the pond, the surface runoff goes into a holding tank, or then it will be pumped back into the pond. From the pond, the water will be pumped into an overhead tank, where it would be distributed for flushing and irrigation. In terms of waste water treatment, in this case, the dirty water from the toilets and the sinks will flow into the wastewater treatment plant, which is in the lower right corner. And the treated water will be stored in a holding tank, which then will be pumped to the pond. From the pond, the water will be pumped into an overhead tank, and then, as we said, it will be distributed for flushing and irrigation. So the pond, apart from the aesthetics, will be used to help and circulate the water around the site, and of course as a temporary storage for rainwater as well as treated water. In addition, water efficient fittings have also been considered to be included into this project. Next slide, please.
Pavlos, could you wrap up in the next 2-3 minutes?
I'm about to finish, yeah.
Yes, super,
Thank you. In terms of energy use efficiency, solar panels will be installed. The target is to have 120 kilowatts, which really represents 20 to 24% energy savings. We'll have energy efficient fittings, as I previously said to you, by using LED lamps, daylight sensors for all lighting, and also occupancy sensors. In addition, we will have a wall building energy simulation, which is also a prerequisition from the lead. Next slide, please. I will go quickly on this one because it's the same principle as has been shown in the previous two examples about natural ventilation and about the stack effect that we should create in order to embrace the natural ventilation. So I will move to the next one quickly. And there is where I will, is the last slide, or I would just emphasize what I said to the audience at the beginning of this project, that influencing the user behavior is quite important, and we believe in that. So this is why this time we will try, for first time in our approach, to encourage car sharing and electric vehicles, aiming to reduce carbon emissions. So this is why we will have 10 units for electric vehicles with charging spots and 10 parking slots for carpooling. In terms of sustainable building fittings, I mentioned to you that we'll have different fittings from water taps to bulbs, sensors, and of course a building monitoring system which will help for future planning and will assist, if you like, in finding areas where savings can be made. The last one. I would like to thank you for listening to me, and I would like also to give the credits to all water and habitat teams and consultants involved in the development of those projects. Thank you very much.